We are talking about essentially three important substrates, that is the macronutrients: carbohydrates, fats and protein. If you ask me, out of the three, the best substrate to be utilized during exercise is carbohydrates, and then fat, and protein is the least preferred substrate. In this module, we are going to learn how we can effectively utilize these substrates for the optimal performance during exercise. Hello, we start with the next module, that is substrate utilization during work. According to me, it's a very important module because however effective your various systems of the body may be, but if the body is not in a position to utilize the right substrate for the right kind of an exercise, it is of no use. So let's understand which are the substrates are we talking about. We are talking about essentially three important substrates, that is the macronutrients: carbohydrates, fats and protein. If you ask me, out of the three, the best substrate to be utilized during exercise is carbohydrates, and then fat, and protein is the least preferred substrate. In this module, we are going to learn how we can effectively utilize these substrates for the optimal performance during exercise. The major substrates which are used during exercise, as I mentioned earlier, are carbohydrate, fats and not preferably proteins. When we talk of carbohydrates, we are looking at blood glucose, glycogen, essentially coming from liver and muscle, the plasma fatty acids and the intramuscular triglycerides, essentially coming from again muscles, blood streams. The currency of energy which is produced in the body is ATP, that is adenosine triphosphate. The ATP is stored in the mitochondria, and when it comes to muscle, the muscle contraction is dependent on the availability of ATP. Why? Because the two contractile proteins in the muscle, that is the actin and the myosin, when they come together to form actinomyosin, they need the presence of ATP, and if ATP is not available, the muscle contraction cannot happen. The question is that this ATP is having a limited storage in the body. So, which means there is a need to generate ATP on a regular basis. One of the system of energy which helps in regenerating ATP quickly is the creatine phosphate. ATP has limited storage in the body, thus there is a need to replenish ATP stores on a continuous basis. One of the ways by which we can replenish ATP on a continuous basis is the system of creatine phosphate, that is the CP, which is available in the body as a part of the muscle. Creatine phosphate can release a phosphate bond and convert ADP to ATP in the presence of the enzyme creatine kinase. But let us understand that this process of conversion of ADP to ATP is anaerobic in nature and is very short lived, that is the duration may be a few seconds. So, such a system can come in handy only for short moment activities like power activities like power lift or a sprint or even a momentary action in a game. So, when we look at the fuel which is coming to the body is essentially from the food, the carbohydrate, fats, proteins. Now, all three of them have the capability to produce ATP. Carbohydrates can produce ATP both in the presence of oxygen and in the absence of oxygen. Fats and proteins can produce ATP only in the presence of oxygen. So, ultimately we use these substrates to produce energy in the body, which is used for work, that is for the muscles which are working during exercise. As I mentioned, the ATP synthesis can be aerobic or anaerobic, and it also depends on the intensity, duration and types of physical activity. In other words, whether the ATP can be synthesized aerobically or anaerobically is determined by what kind of exercise are we doing, what is the intensity of the exercise and what is the duration of the exercise. Let us first look at the anaerobic pathway. The anaerobic pathway is also called as the lactic acid pathway or anaerobic glycolysis. It takes place in the cytoplasm. It is a major pathway during low intensity exercise when the availability of oxygen is very limited. Most glucose is used from the muscle glycogen, and what happens is that the end product of this pathway, which is lactic acid, tends to get accumulated in the muscle if such pathway is continued for a relatively longer period of time. So, through glycolysis, glucose is converted to pyruvic acid and pyruvic acid is converted to lactic acid, and during this process ATP is produced. This pathway is also of limited time duration and it may last from 60 to 120 seconds. As intensity increases, the lactic acid cannot be used as a fuel source and it tends to get accumulated in the muscle. It tends to lower the pH, which in turn interferes with the enzymatic action of the muscle cell and it results in muscle fatigue. Let us look at the aerobic pathway. It is used for activities lasting longer than 90 minutes. It takes place in the mitochondria. The pyruvate formed from the glycolysis enters into the Krebs cycle through acetyl coenzyme A, and Krebs cycle takes place in mitochondria. Let us also understand that acetyl coenzyme A is one intermediate product which can be formed from beta oxidation of fatty acids as well as from amino acids. So, what does it imply? That both fats and proteins can enter Krebs cycle and help in the generation of ATP. However, the preferred source of energy is carbohydrate, but the point to be remembered here is that carbohydrate, fats and protein can enter this aerobic pathway by forming the intermediary product acetyl coenzyme A in mitochondria through Krebs cycle. Through this pathway, there are 36 ATPs which are produced per molecule of glucose, and because of this it is considered to be a very important and effective pathway to be maximized on to ensure availability of ATP to the working muscles. So, in essence, what we are trying to reflect is that there could be anaerobic glycolysis, there could be aerobic pathway. Anaerobic glycolysis converts glucose to glucose 6-phosphate in the presence of ATP, which gets converted to pyruvic acid, and pyruvic acid gets converted to lactic acid, and this generates 2 ATP. On the other hand, in cytosol anaerobic pathway, in liver, glycogen can be converted to glucose 1-phosphate, glucose 1-phosphate to glucose 6-phosphate, and ultimately that gets converted to pyruvic acid, and this pathway releases 3 ATPs. Now, pyruvic acid gets converted to acetyl coenzyme A, which gets routed to Krebs cycle followed by the electron transport chain, and this entire process happens in the mitochondria and releases 36 ATPs. Even though we said that fats and proteins can be used for the purpose of energy, but using protein for the purpose of energy is not a healthy state of the body. So, the preferred source of energy for body are carbohydrates and fat. Now, what are the factors which affect substrate utilization? One, of course, the intensity of exercise. As we said, the intensity of exercise has a bearing on the availability of oxygen, because as the intensity of the exercise increases, the VO2 max decreases, and if our conditioning is not good, we are not fit enough to take that intensity of exercise, we will very quickly switch from aerobic mode to anaerobic mode. That means our substrate utilization would get limited only to carbohydrates, and anaerobic mode of carbohydrate utilization leads to the synthesis of lactic acid, which on accumulation can cause muscle fatigue. On the other hand, if we do a moderate intensity of exercise wherein we work towards a target heart rate zone as per our age, as per our level of fitness, we somewhere oxygenate our body at the rate at which the body needs to make oxygen available to use fat as a substrate for utilization. Now, let us remember that fat can only be used as a substrate in the presence of oxygen. So, if the intensity is kept moderate, we are helping our body to use both carbohydrates and fat as a substrate for utilization. Then comes duration. As mentioned earlier, that anaerobic mode of substrate utilization should be used for a very short duration of time. That is for spurt activities, for a sudden hit in football, for a ace service in tennis, or sudden power activity which needs the immediate release of energy is something which gets supported by the anaerobic substrate utilization. When it comes to aerobic utilization of substrate, it is always a longer duration. So, it is very clear that as the duration of the exercise increases, the mobilization of substrate moves from anaerobic to aerobic, because with the increase in the duration of exercise, we also increase the availability of oxygen. Now, there are a number of nutritional factors which will also govern the substrate utilization, and that has something to do with the kind of diet which we consume. The diet which we consume has to be adequate in carbohydrates, both quantity and quality, has to have good amount of proteins, so that proteins are spared for the purpose of anabolism, and should have fats in adequate amount to make up for the caloric density. Again, what is important is that the quantity and quality of fat has to be kept in mind. The environmental factors would also affect the substrate utilization. If we work in hot environments or cold environments or humid environments, again the shift of the body to anaerobic substrate utilization may be higher, because all these factors can have an influence on the availability of oxygen and the comfort of the body to perform the optimal exercise. The body stores again is important, and depending on how much body stores are available, especially in the form of glycogen which is stored in the muscle, and that is why it is always mentioned that whenever we take up a workout or a sport, we must know the muscles which we are using. These muscles should be strengthened through resistance exercises. Purpose is, when we strengthen the muscle and when we support it with adequate carbohydrate intake, we replenish these muscles with glycogen stores, which comes in very handy to give optimal performance during workouts and sports. There are a number of hormones which have a role to play in the substrate utilization. Most important being insulin. We know that insulin deficiency can lead to lack of carbohydrate mobilization, or excess of insulin can also make insulin resistant to use carbohydrate. Similarly, the other glucogenic hormones, whether it is cortisols or glucagon, their levels also have a role to play on the preferred mode of the body to use a substrate for energy. So, let us talk a little more about the effect of intensity on substrate utilization. Let us compare the low intensity exercise to moderate intensity exercise. In the low intensity exercise, as I said, 25% of VO2 max is used, whereas for moderate 60 to 70% VO2 max is used. We may consider aerobic pathway in low intensity exercise and moderate intensity exercise, but only intensity does not help. Intensity has to be clubbed with the duration, then only we help our body to use fat as a substrate for energy. Now, considering that lipolysis is the methodology through which triglycerides are released from adipose tissue, when we compare the rate of lipolysis in low intensity exercise, we find that it is 26 micromole per kg per minute, whereas in moderate intensity exercise, the plasma fatty acid and intramuscular triglycerides are oxidized and the rate of fat oxidation is higher, that is greater than 40 micromole per kg per minute. About half of the total energy is obtained from muscle glycogen and blood glucose. So, what we are trying to emphasize here is that when we do low intensity exercise, we may be in a aerobic pathway, we may be using more of glycogen, and there may not be an increase in the blood lactate level, but this would last only for a shorter duration of time, whereas if we use a moderate intensity of exercise, we favor not only aerobic pathway, we favor the oxidation of fats, we favor the oxidation of muscle glycogen, and so there is a mobilization of fats and carbohydrate for the purpose of energy, and the outcome can be that the blood lactate levels increase. So, all 4 major substrates can contribute to energy production in moderate intensity exercise. When we go to high intensity exercise, again we are looking at a VO2 max of 85%. The major contribution again comes from carbohydrates, because we switch to anaerobic pathway whenever we move towards high intensity exercise, and with the anaerobic pathway there is increased glycolytic flux, there is increased muscle glycogenolysis and increased overall glucose oxidation, again leading to increased accumulation of lactic acid and leading to muscle fatigue. There is decrease in free carnitine and a decrease in pH, which is a clear sign that fat cannot be mobilized as a source of energy. The intramuscular triglycerides may be tapped to be converted into fatty acids and used as a substrate, but whenever we move from aerobic to anaerobic pathway, there is a hormonal change, there is a change in the availability of carnitine, and as a result of which the CPT1 is inhibited, leading to reduced long chain fatty acid oxidation. The limitation of carnitine and its phosphorylation the increase in malonyl coenzyme A, the change in the ratio, all these factors prevent the fat to be mobilized to mitochondria, and thus more and more carbohydrates are favored to be utilized through anaerobic pathway. So, this diagram clearly shows the relative substrate utilization as we increase the intensity of the exercise. You can see that from low to moderate to high. Now, the parameter by which we determine the intensity of exercise is the VO2 max. So, for the low intensity exercise, as we can see that the utilization of fat may be higher. As we move to moderate exercise, we find that the utilization of fat and glycogen happens equally. That means both the substrates are utilized, and as we move towards high intensity of exercise, it is more of glycogen which is used. Now, effect of duration on substrate utilization. Like I mentioned that it is just not the intensity of the exercise, but intensity has to be clubbed with the duration of exercise. As the duration increases, the use of free fatty acids increases. Increase in fatty acid oxidation is because of the depletion of glycogen stores, greater dependency on aerobic pathways in long duration endurance exercise. Short bouts of exercise such as weightlifting utilizes the anaerobic pathway. There is increased oxidation of fatty acid due to increase in catecholamine and decrease in insulin levels with increasing duration. Lactic acid may be used as a fuel source only in short duration exercise, only in trained athletes, and the condition when both liver and muscle glycogen stores are depleted and fat becomes the major energy source and fatigue sets in is referred as hitting the wall. Now, the point which we want to emphasize through this duration and substrate utilization is that as we increase the intensity of exercise, the duration of exercise tends to become lower. So, that means we are shifting the balance towards more of anaerobic pathway. But if we maintain a moderate intensity of exercise, we can continue that exercise for a relatively longer period of time, which means we are tilting the balance more towards aerobic pathway, and thereby we are facilitating the utilization of fat. So, whenever we are working on a program where we want to lose fat, we should not be looking at extremely high intensity exercise, rather we should be looking at moderate exercise for a longer duration. So, say for example, if I am working on a treadmill and my objective is to lose fat, and if I start running on the treadmill at a speed of 12 and 14, that is a high intensity exercise, and I may run for a shorter duration, I am really not helping my body move to an aerobic mode of substrate utilization, and I am hitting myself more towards the anaerobic pathway. So, what I am helping my body is definitely to improve my cardiorespiratory fitness, but I am not helping my body to use fat as a substrate for energy. Whereas, on the other hand, if I want to use fat as a substrate for energy, the first step is that I must know my target heart rate zone. I must maintain my heart rate within the target heart rate zone, keeping my age, my level of fitness in mind, and then in that range I should try and keep my intensity moderate and work out for a relatively longer period of time. Then only I will be in a position to equate the availability of oxygen with the need of the oxygen by the fat to be used as a substrate for energy, and this would lead to fat utilization. So, let us summarize the fuel, the duration, and how do these fuels work. So, very short duration, like less than 3 minutes, the fuel which is used is muscle glycogen, liver glycogen is negligible, free fatty acids negligible, amino acids negligible. Short duration less than 40 minutes, muscle glycogen high, liver glycogen high, and free fatty acids low, amino acid negligible. Moderate duration, that is 40 to 150 minutes, muscle glycogen high, liver glycogen high, free fatty acid moderate, and amino acids low. Longer duration, that means greater than 150 minutes, you have muscle glycogen moderate, liver glycogen moderate, free fatty acids high, and amino acid low. So, as we increase the duration and keep the intensity moderate, we move our body to favor more of fat utilization as compared to glycogen. So, there could be a time where we are using less of glycogen and more of fat with a longer duration of exercise. Hormones affect the substrate utilization, as I mentioned, that increased catecholamines, glucagon, growth hormone, cortisols, these are all hormones which favor change in substrate utilization. Decreased insulin with increasing intensity and duration. So, this would benefit and favor the carbohydrate utilization. Increased glycogenolysis and glycolysis in liver and muscle when the catabolic hormones are increased. Increased lipolysis in muscle and adipose tissue, more when fat is being mobilized as a substrate for energy, and increased gluconeogenesis in liver, again an effect of the insulin resistance, which is favoring the use of other substrates for the production of glucose, and increased protein degradation again in the presence of catabolic hormones. So, the effect of hormones on substrate utilization creates a difference in substrate utilization also in men and women, because men and women react to different conditions, and the difference many times between men and women is also hormonal. So, which has a substantial influence on substrate utilization. What is the effect of training on substrate utilization? Repeated episodes of physical activity results in adaptation to utilize a substrate. Trained individuals have a better ability to utilize fat as a substrate. Anaerobic training results in increased intramuscular levels utilization of anaerobic substrates like ATP, phosphocreatine, glycogen, or increased quantity and activity of enzyme that control the anaerobic phase of glucose breakdown. Increased capacity to generate high blood lactate levels during maximal exercise. So, the point which is made over here is that when we get training, the training can be also at the anaerobic level to use the substrate effectively. That means, we can use muscle glycogen anaerobically, and if we are trained, we can use the enzymes, the substrates more effectively without generating high blood lactate levels, which means in spite of using anaerobic substrate, we may not get muscle fatigue if we are training ourselves anaerobically to utilize substrate. On the other hand, aerobic training results in a number of adaptations. There could be increase in the mitochondrial size and number, which improves the capacity to generate ATP. There could be increased enzymes of the aerobic system, which lowers the lactate accumulation. There could be improved ability to oxidize stored triglycerides, and there could be decrease in the utilization of blood glucose and muscle glycogen. So, the aerobic training definitely favors the utilization of fat as a substrate for energy, and there are adaptations in terms of the mitochondrial size, the capacity of the aerobic system to use the substrate more effectively and generate more and more ATP. The effect of environmental conditions on substrate utilization. Effect of altitude. Carbohydrate utilization is increased at high altitude. Lactate concentration is higher at high altitude than at sea level. Free fatty acid levels decrease at 15 minutes in both the conditions. Effect of heat exposure, increase in body core temperature will result in increased glycogen utilization by the muscles, and effect of cold exposure also contributes to increased utilization of carbohydrates. In fact, extreme cold temperature causes shivering, which results in heat production. Shivering causes an increase in hepatic glucose output and increased glucose utilization. The substrate utilization for exercise can be done through aerobic pathways and anaerobic pathways. Now, which pathways get used has a bearing on a number of factors. The first thing which we learned, that the most preferred substrate for energy in the body is carbohydrates and fats. The body does not want to use protein for the purpose of energy. Rather, the body wants to spare the protein for the purpose of anabolism. The intensity of the exercise can be low, moderate and high. Low and moderate exercises favor the utilization of fat as a substrate, and high intensity exercises push the substrate more towards carbohydrate. In fact, the substrate utilization even for moderate exercise can be a blend of carbohydrate and fat, but with the intensity we also have to look at the duration of exercise. So, if the exercise is low to moderate for a longer duration, the body is favoring more of aerobic pathways to utilize carbohydrates and fat, and between carbohydrate and fat, if we favor aerobic pathways, it is the fat utilization is better. As a result of which, the fat loss can happen if we are on a fat loss program. On the other hand, if we are looking at high intensity exercises for a shorter duration of time, because of the dipping of VO2 max, the body is likely to go into anaerobic mode, and thus automatically the body moves towards the utilization of more and more carbohydrates, thereby generation of more of lactic acid and muscle fatigue. So, it is very prudent for all of us to plan what substrate the body should use, whether the body should use it aerobically or anaerobically, which substrate should be preferred in which type of workout and which type of sport. So, a clear understanding of substrate utilization, the type of substrate, the pathways, the intensity and duration is of utmost importance.